Good morning. I'm Chris, working for Microport, living in Belgium. Would like to thank you all for the invitation, and always happy to be here and to meet you all to discuss some interesting stuff around orthopedics. I think my presentation was initially intended as a sort of introduction, but I think now it could be more like a summary and hopefully some fruit for discussion. So when we talk alignments in total knee arthroplasty, it's a lot of companies and a lot of different manufacturers, they say that they try to give an answer to the dissatisfaction of patients, either by providing a new technique, either through mechanical, kinematic alignment or functional alignment, and they try to overcome the 20% of unhappy patients, either by the implants or by the alignment of the prosthesis. So very important to understand before we go into the different alignment ways. I want to talk to you about the constitutional varus, which is quite important to understand when you start talking about alignments, is when you look into the total population of knees, is that if you want to go for a complete neutral alignment, which in quite a bit of alignment techniques is the goal, is that only 15% of the patients can be treated with neutral alignments, especially with male where the percentage is really high, whether there is a constitutional varus or and also with females. So it's very important to understand that the concept of constitutional varus and the limitation if you want to treat the patients with a total knee arthroplasty. Quite important also is, we touched base probably in some of the previous presentations, you don't only have the alignment technique, the way you do surgery is either by bony cuts or by ligament releases, but you also have to know which implant you're using, how thick is the metal, how stable is the implant, and how does the femur correlates to the tibia. So very important steps to remember. So if we go to the different alignment techniques, it's going to be an overview of what has been done or still done in the orthopedic community. So first of all, the first alignment technique we want to touch base on is the mechanical alignment technique, which is still the golden standard in many of the surgeons' practice, and also the anatomical alignment. So if we look to the mechanical alignment, the objective of the end of the surgery is that the axis goes through the center of the knee. So and the tibial cut typically is more medial than lateral. If we look for the tibial resection specifically, you want to have a perpendicular cut on the mechanical axis, which in this case is also the anatomical axis, to make your bone cut on the tibia. For the distal femoral resection, that is based on the perpendicular to the mechanical axis, and the femoral, the anatomical axis is used to make the valgus angle correct. So the femoral posterior condyles is the posterior resection is done based on the posterior condyles and is to create a rectangular gap together with the tibial resection. So in terms of mechanical alignments, without going in detail over all these different lines of reference points, such as the white side line, the sulcus line, and many other lines that are being used to make a good relation and a good orientation of the implant on the femoral bone. I think those alignment or those reference points are all familiar for everybody. But in what we try to do is to have inflection and extension in a rectangular space, and depending on the tightness, either inflection or an extension, there might be a downsize or there might be some more cuts done on the femoral bone or on the tibial bone, depending if you're talking about the flexion or the extension. But in many cases, if you stick to the pure mechanical alignments, you can get good results, but you will have a tendency to do a little bit more ligament releases. So an evolution of the mechanical alignment was the adjusted mechanical alignment, which means that you basically try to start from the same starting point of mechanical alignment, but you try to play around about 3 degrees with your frontal deformity and the frontal alignment to have less ligament releases at the end of the surgery. So again, for the tibia in this adjusted mechanical alignment, you start from the same starting point, so perpendicular on the tibial axis, nothing different there. And from the femur, you try to play with the 4-in-1 and the implant position to play with the amount of external rotation and with the amount of varus valgus, again, as an end result, to try to have a little bit less ligament releases. So the idea is to accommodate the femoral bone resections in order to not to have too much aggressive ligament releases when you're doing the balance at the end of the surgery, or have the final balance at the end of the surgery. Some surgeons try to achieve this by prophecy gap balancing. This is a personalized instrumentation combined with a specific instrument kit, allowing you to play around on the femoral side to give more or less valgus alignment, or to do the external rotation on the femoral component. The next alignment technique is the balanced alignment technique, which means that at the end of the surgery, you want to have both your extension and flexion gap equal, rectangular, and balanced. So again, tibial resection is perpendicular on the tibial mechanical axis, and the tibia acts as the starting point of the rest of the surgery. So from the tibia onward, starting with the femur, you will start by using a balancer. You will start doing the cuts on the femur, both in flexion and extension, to have an equal, rectangular, balanced extension and flexion gap. So because you are very using the balancing technique and you're using the ligaments, the ligament releases might not be needed following the balance technique. And the surgery is basically totally driven by ligaments, and that is the pure prophecy gap balancing, where you send the protocol or the X-rays or CT scan to an engineering department in Microport, that is in Costa Rica, where they make all the necessary planning, and they send you back some personalized instrumentation, which together with an instrument kit allows you to perfectly align the implants based on the tension of the ligaments. So a little bit more different is the anatomical alignment. I have that has been around the late 70s, early 80s, where the objective is to keep the joint line oblique without touching the ligaments. So what they try to do with anatomical alignment is make a correction on valgus correction of about 3 degrees on the, or keep 3 degrees valgus on the femur, and have 3 degrees varus on the tibia, and to have an overall neutral alignment. So as mentioned, the tibial resection is try to keep at 3 degrees varus, and then for the femur, the femoral cuts are made by adding a 3 degrees when you're referring it to the femoral mechanical axis. So and the femoral cuts on the posterior part are done in 0 degrees of external rotation. So when an end results, you have an implant or a gap which is angled in, as you can see, in extension and flexion into oblique to compensate for, or to, as a result of the cuts you made on the femur and on the tibia. The problem with the anatomical alignment in the 80s was that they saw some early failures on the tibia, either to wear or to the difficulty in reproducing the 3 degrees varus, or the exact 3 degrees varus, and as a consequence, the technique was abandoned. Then more recently, Steve Howell started working a lot on the kinematic alignment. In the beginning, addressing all sorts of deformities with kinematic alignment, but the objective of a kinematic alignment is to restore the native joint line, and it's based on the pure kinematic alignment is based on the technique that you start with the femur first. And at the end of the surgery, you want to put the metal implants exactly at the space or at the place at the same thickness where the original native surface of the femur was. So the femoral cuts are made on the hypostasis, or the idea that you know where the original bone was, including the cartilage. And some instrumentations allow you to measure. There are some special chisels that allow you to measure the thickness of the cartilage, both medial and lateral. And that thickness can be transferred to your valgus alignment module, making sure that you have the correct alignment of the femoral cuts in line with what the native surface of the femur was. So also very important is as you want to match the implant to the bone, is to make sure that when you do your bone resection is that you caliper and you exactly measure the amount of bone you remove to make sure you're putting the metal in equal to the original bone including the cartilage. So when you're doing your distal cut, as mentioned, because you're measuring your cartilage thickness, there is a valgus module on the microport instrumentation. The valgus module allows you to keep the valgus module loose and compensating and looking for the 2 or 1 millimeter compensation of the cartilage you lost, and as such, decide which valgus angle you are using on the femur. Obviously, within a certain amount of acceptance of variations. But if you go purely all the way with this alignment, a 8 to 9 degrees valgus is not unusual. The posterior cuts are made in a 0 degree of external rotation, and obviously there is no ligament releases intended when you do a kinematic alignment because you want to preserve the soft tissues as much as possible to have the patient up and running quickly. In terms of the tibia cut is mainly done to create the possibility to create the exact amount of space you need for the extension stability. In some of the instrumentation, you're able to measure the stability or the flexibility in the joints and introduce that in your cuts you make on the tibial bone. So you can, on a medial lateral side, you can vary the amount of bone you remove based on the bone or the cartilage that is there or not there. So we said we are taking into account the cartilage wear on the plateau. We try to restore the native slope, and the tibial cuts most of the times are made in about 3 degrees of varus, and we try to limit that not to go too much into the extremes. What you see when you do a pure kinematic alignment is that if you go from mechanical alignment and you look to your tibial bone cut, if you compare both, you will see that you have the tendency to have a little bit more bone removed on the tibia when you have a kinematic alignment versus a mechanical alignment. So the corrections during this surgery are made to create a rectangular space in extension, and that is not necessarily needed in flexion where the space can be trapezoidal. There are obviously in the instrument kits also tools to fine-tune whether that would be needed to make an additional correction of the slope or some additional varus if that would be required, or less varus. There are additional blocks that can do that. So when you talk kinematic alignment, the first rule is that the bone wear is negligible and the cartilage wear is predictable and in microport instrumentation measurable, which means that in average in the distal femoral bone, it's about 2 millimeter of cartilage which is lost, and the posterior wear in varus knees is you can ignore, and in on the lateral side in valgus knees, it's about 1 millimeter compensation you have to take into account. Another important aspect is that you need to understand when you do kinematic alignment the different axes that are in the knee. So you have the transverse axis, which is described by Hollister, which is the green one, as you can see on the drawings over there, which is basically recreating the single radius. But then on top of that, there is the single transverse axis, which is defined by Cochrane in 2003, which is basically the axis where the patella flexes around the tibia and the femur. And then depending on which philosophy you follow, in this case, we are talking about medial pivot, so which is the axis, the vertical axis is going through the medial compartment, and then depending on some of the implants, they describe to go it through the middle. But with medial pivot, they go through, ideally, they go through the medial side. So, and the third rule is, as mentioned before, the extension gap can be rectangular, and that is not necessarily for the flexion gap. So if we talk a little bit about dogmas on the kinematic alignments, we never correct the femur. We try to put in exactly the amount of metal that was in the original anatomical bone. We try not to touch the ligaments, and the corrections are made on the tibia when it comes to varus valgus, the slope, and the resection level. When we look into kinematic alignments, and we mentioned that the extension gap, and you put the femur and the tibia together, and then you, on top of that, you add a medial pivot, you have basically the ideal construction for a quick and early recovery of the patients. And as mentioned in the beginning, when you're using this, it's quite easy to keep the patient in a constitutional varus and have a good results in the end. More recently, because kinematic alignment initially was addressing valgus and varus without too much limitations, we have seen that there are limitations when you use kinematic alignment, especially when you talk about the extremes. So when we talk about restricted kinematic alignment, they want to reproduce the patient's constitutional knee anatomy, but within a safe range. So that is quite important to understand. Most of the cases can be treated with a conventional pure KA, but those cases, they try to limit it within 3 degrees of variation. So, the fixed point number 1 is that you try to reproduce the individual lower limb anatomy while you're keeping the angle of the knee at a 3-degree range. So as you can see, there is the study mentioned here that there is a lot of difference when you're treating patients. And there are some other studies which I forgot, but Dr. de Brabander can maybe comment on later, as the phenotypes and so on, and how that works with kinematic alignments specifically. But there are some limitations, and therefore restricted kinematic alignment might be beneficial to do. So the fixed point is that reproducing the individual anatomy while keeping the lateral distal femoral angle and the proximal tibial angle within about 5 degrees. So when there is a need for soft tissue releases, that's typically when you cannot keep the alignment either within the fixed point 2 or the fixed point 3, the 3 and the 5 degrees we talked about earlier. Having said that, there are, and coming back a little bit to different types of treatments when it comes to restricted and kinematic alignment based on a lot of algorithm. This is one of, if I'm not mistaken, Professor Ventitoli from Canada, but there are some other structures that allow you to decide which type of alignment you would use in a specific patient with too much varus or valgus in the knee. You have also the inverted kinematic alignment, which is to reproduce, again, the patient constitutional knee anatomy within a safe range. But the difference with the inverted kinematic alignment is that you start from the tibia, and then you transfer that to the femur. So typically you take about 5 to 7 or 8 millimeter section from the tibial side, and then the femoral bone cuts are parallel to what you have done on the tibia. Also here, you try to limit or you don't do any soft tissue releases. And if you compare it with the direct or the pure kinematic alignment, you will see that the pure kinematic alignment starts from the femur, while the inverse kinematic alignment starts from the tibia. The kinematic alignment accepts any joint line angle, while the inverse kinematic reduces the joint line varies to 2 degrees. And the kinematic rotation is based on the posterior condyles, while the inverse kinematic alignment slightly external rotates the component to address the patella. More recently, either by usage of robots or navigation or augmented reality, there is more and more talk about functional alignment and or specific patient alignment. And the idea is that you restore the function and the alignment that is specific for that, beneficial for that patient, and keep the joint line as it is. You try to restore the native plane and the obliquity of the joint, and you stay within the dedicated joint soft tissue envelope. As mentioned, with these type of techniques, pre-op planning is quite important. Either through planning on the PC or by using a robot or by using, for example, Pixie or augmented reality that allows you to correlate your pre-op planning and then execute with the use of instrumentation or a robot the alignment of the cuts on the femur and the tibia. As you do this specific functional alignment or patient-specific alignment, and the measure, and you execute exactly what you measured. Most of the time, you do not need any ligament balancing at the end. So when we talk about those last, as mentioned, to perfectly execute on that, it's very handy to have either a very, very dedicated instrumentation, allowing you to measure the cartilage, allowing you to transfer the balance so that you have from an uncut femur and translate that to the bone cuts you make, or you use augmented reality, which could be Pixie or any other device, or you use a robot to achieve that. Thank you.